Hello everyone, my name is Mrunang Pawar and I am a student at Srimati Kashibai Naule College of Engineering, Pune. We are elated to bring to you yet another module of HTM Qubits, Quantum of Workshops back together. This is our 23rd session of the highly engaging HTM Qubits, and we expect this one to surpass the awesome response we have been getting for the past 22 sessions. This session is to introduce you all to Rust, the language that can last a lifetime. Are you one of those who has always wanted to learn Rust but don't know where to start? Here is your chance to know more about Rust, a multi-paradigm programming language designed for performance and safety, especially safe concurrency. This session is dedicated to be your beginner's guide and help you dive deeper into Rust. To guide you through this session, we have with us Faisal Ahmed Farooq. He works as an intern at Linux Foundation and he is also an MLH Fellow. His experience in this field makes him more than qualified to guide you through this workshop. So, without any further ado, I would like to hand over this session to Faisal. Over to you, Faisal.
Hey everyone, thanks for joining, and I hope this session will probably inspire many of you watching to take up Rust. And yeah, I think let's get started with the presentation, I guess. Yeah, so Rust, a language that can last a lifetime. Now, the reason why I'm saying lifetime is because I want to emphasize on the fact that this programming language could, end up being a part of our ecosystem for the next, 20 to 30 or 40 years, just like how C or C++ has been. Uh, just a sec. Yep. Yep. So about me, and yeah, like already mentioned that I've been an MLH Fellow and LFX mentee, and currently I'm working on Rust bindings for VPP, a vector packet processor. And my day job, daily what I do is go through a lot of Rust code, interpret it, and try to strategize how to create bindings for Rust. And let's get started with what is Rust. I think if you would just Google what is Rust, you would get the definition that Rust is a multi-paradigm programming language designed for performance and safety, especially safe concurrency. I would call this a textbook definition. So, what would multi-paradigm mean is that paradigm basically means that we have different programming paradigms. We have object-oriented, we have functional programming, and Rust provides ways in which you can either have an object-oriented approach or a functional programming approach. So it's like Rust is taking the good bits of everything and using it. So that's Rust. Now for Rust for students, for who's students who are interested in Rust. So why should they learn Rust? So like the reason why students should take up Rust is because while learning Rust, you learn a lot of systems concept. You learn about operating systems, and there are many who, while learn about memory management and operating system concepts, which they would traditionally not learn while learning C or C++ or Java. And that's a great introduction into systems programming through Rust. And Rust is also for people who crave for speed and stability, because Rust ensures that the safe code that you write is also it is also very fast. Uh, uh, Yep. So before we dwell into more into Rust, I want to talk about how Rust is being adopted currently in various companies. The first company that I would like to talk about is Dropbox. So Dropbox is currently using Rust in their synchronization engine, and they've mentioned that Rust's easy ergonomics, I don't know how you pronounce it. So uh, it has helped them to basically tame the complexity of a synchronous engine, and that's one place. Next we have Amazon. So Amazon, in parts of EC2 or Lambda, where performance is really important, Rust is being implemented. And they also have a full Rust service, something called as a Firecracker VM, which is also open source, which used to monitor services like AWS Lambda and AWS Fargate. Next, we have Microsoft. The thing is that Microsoft is currently trying to migrate or integrate Rust into their C and C++ code base. Now, back in 2018, Microsoft reported that for the last 12 years, they've had 70% of their vulnerabilities were due to memory leaks. And over the past 12 years, they've tried their best, to have like different tool sets to reduce this. But the only way they think they can move forward is by totally avoiding these memory safety problems. And that's how Microsoft is trying to use it. And then we have Discord. So I think everyone's familiar with Discord. So Discord uses Rust in various parts, that is in the client side and server side. And then we have npm. So if there are any JavaScript developers here, I think it's pretty ironic if you think that Rust is being used for npm. So npm engineers thought that they would opt for Rust. If they wouldn't opt for Rust, then they would get bottlenecked by various requests on a daily basis. And the reason they went for Rust instead of C or C++ was because of the memory safety it provides. And they didn't use Java because they didn't really want to set up JVMs in many of their servers. So yeah, so these are some of the companies that are currently using Rust, and how Rust has basically helped them in performance. Now the real question really is that what makes Rust tick? Now these companies aren't companies that have written 10 lines of code and then migrated to Rust. It's literally tens and thousands of lines of code that they have decided to migrate to Rust. And you should really question, because we as individuals, we always think even 10 or 20 lines of code that we write, we are always arrogant and so loyal to a certain code base that we think it is the best. But you really need to think that these companies have decided to take Rust and migrate to Rust, literally rewriting tens and thousands of code, because there's a reason. And let's explore what this reason is. So the first reason is that the code needs to be really fast. uh, Rust is literally a systems programming language, but it has basically outgrown from the term systems programming language, because it can be used for various things, that is for web services or so many other things. I think I don't remember all the applications, but yeah, but majorly it's really fast. And normally it's not a problem to go fast, but there is usually a trade-off. So if you would write fast code, then it's also very dangerous. And if you write code which is safe, it's probably very slow. This is how you can compare like C++. You can write code which is very fast, but it's also very dangerous because there is no garbage collector with C++. At the same time, Java has a garbage collector which allows you to write code which is safe. So there is a trade off. So if you write speed code, you can't have that safety. And if you have safety, you can't have that speed. And that's where Rust comes in between, where you can have safety as well as speed. But there is always a drawback. You can't say that. If I would say that Rust has no drawbacks, then I'd probably be lying, because there is a drawback somewhere or the other. That's where the universe balances itself. So compiler. So the Rust compiler. So like I said, that Rust has both speed and safety. That is possible because a lot of the bugs that are presented to Rust are through compilation times. And uh, when you have production, when you get production bugs in compilation time, that's the best time to get the compilation. Sorry, that's the best time to get these bugs and fix them. And that's where the trade-off is. So Rust programs generally take a lot of time to get compiled as compared to C or C++, because the compiler makes sure that everything runs perfectly, make sure that there aren't any dangling pointers or there is a problem of ownership and stuff like that. So but once the compilation is done, then it can literally solve around 70 or like Microsoft mentioned that 70% of their bugs could be solved if they used Rust. So that's a good thing. But another trade off is that there is a huge learning curve. It's not easy to learn Rust, because it's not as easy as learning Rust as easy it is to learn JavaScript. Like I said, like there are a lot of things that go, because a lot of the errors are found out in the compile time. So like if something that you suppose you write something like a linked list in C, you can pretty much write the same thing in C++ and pretty much the same thing in Java. So you can easily do that. But when it comes to Rust, you really need to think and write code that is safe as well as fast. So that is basically the trade off. But the way that compilation takes place is that the compilation messages, the error messages, are very friendly. So it's not like when you compile code in C, C++, you would think that the compiler is not letting you compile the code. But because the error messages, although if someone is experienced with C++, they can easily interpret it. But if someone who is not experienced, then these messages seem rather vague and you can't really interpret it. And that's where Rust has, tried to reduce this drawback of large compilation times by having a friendly compiler. And these are some of the messages you would get from the compiler if you have any errors. And over here, like I said, that Rust is memory safe, and the compiler basically looks at these production bugs. So you can't have like multiple borrows. So borrowing and ownership is a concept used by Rust to manage the memory. So basically, like the compiler itself is the garbage collector for Rust, and that's how Rust is fast. And one more thing is over here, I think this is pretty interesting, is that y is equal to 1 by 0 is actually you can see it during compile time. So C and C++, you would get that error during runtime. So yeah, that's just meant to show you like how all of this is recognized in compile time. However, these are very basic errors, not really something that can represent a production bug. So what is memory safety? I think I've mentioned memory safety a couple of times. I think in the last 5 slides, I might have mentioned it around 6 to 7 times. So, what does memory safety really mean? So, how is Rust making sure that the memory is safe? That is, there aren't any bugs that are related to memory. So, if you are someone who's familiar with C or C++, you normally have functions like malloc, alloc, and free. So, these functions are used to create pointers that have data on the heap, and heap is basically where you store data that can grow over time during the runtime. So often what happens is that one of the most basic example of a memory bug would be that a dangling pointer, that you would allocate memory on the heap but you would forget it to free it. And that has been one of the most common memory safety issue. So memory safety is not something that happens as the program runs. It happens because uh, you haven't really written the code very well to handle memory. And one could really argue that we can do the same thing with C and C++. If we write code that is memory safe, then why do we need Rust? So the problem really is that, is there a programmer that is better than programmers in Microsoft or the other companies I mentioned who can write code which is much safer than the code that they have written? So that's where you really think that it's better to not have such mistakes at all than have it over there. So like the saying goes, like prevention is better than cure. So that's basically what memory safety is, and Rust basically solves this. So during compile time, the compiler would make sure that there aren't any such dangling pointers or yeah, any other memory issues. uh, Type inferences. So I think Rust is a statically typed language. So you have to define all the types of the variables before compile time. There's TypeScript that implements this, but it's for correctness. And there's Java that implements this for correctness and performance. But Rust also has this for correctness as well as performance, but there's more focus on the performance part because Java has a garbage collector, and 9 out of 10 times maybe you might not feel like Java there is a big performance issue, but there is generally a lot of problems when you have a garbage collector, when the garbage collector would interrupt and then clean out memory. So that's where the problem is. So that's basically how Rust is. We have to mention the type of each variable before compile time so that it gets compiled. So yeah, what is WebAssembly? Yeah, so I was going to talk about how Rust and WebAssembly is. So basically, what is WebAssembly? So WebAssembly is neither web nor assembly. That is, WebAssembly is a way in which we can write system level programs and convert it into uh, code that can run on the web. So one of the things is that yep, yeah. So uh, as I've mentioned earlier, that Rust is better than C or C++. That is because of memory safety and performance, and basically zero cost abstraction. And uh, one of the things is that to achieve this WebAssembly, that is, WebAssembly is very great with Golang, and Golang has been providing various toolchains to work with WebAssembly. And Golang is great, but also at the same time, Golang has a garbage collector too. And one of the problems that Golang faced, that is one use case where Golang was replaced with Rust, was on Discord, where Golang had a garbage collector which affected the latency too much that they had to rewrite parts of which was written in Go into Rust. And yeah, so that's where Rust uh, and WebAssembly are a great combination, basically because Rust is memory safe and it's very fast. Yeah. So one of the things is that one of the things is that runtime. So what does runtime even mean? So runtime basically means that once whenever you're compiling, when you're executing the program, then the compiler would add code to your existing program that is outside the scope of the program. So systems programming languages like C or C++ have like a very small amount of runtime. As you can see, this green square indicates this runtime. So an assembly language has like zero to negligible amount of runtime. And if you would see that JavaScript, something written in JavaScript, has a huge runtime. So when you're compiling with Wasm, then that runtime which you have with Rust or which you have with JavaScript, you're taking it with you. So that's why, like, even though you can write WebAssembly stuff in JavaScript, it's not really a great way, but it does give you some improvement in performance, but it doesn't really benefit you in any way as much as Rust would do, or even C or C++ would do. So that's why a combination of Rust and WebAssembly is great. And there are community has basically written tool chains around this, and one of them is basically U. I don't really know how you pronounce it. It's YEW. U or U, I don't really know. So so it's basically a Rust WebAssembly framework that is pretty much inspired by React. So I'm someone who's come from a React background, that is writing JSX and stuff like that. It's pretty easy for me. And one of the things that I really liked about it was that it has syntax which is very similar to React, and it's very easy for you to write stuff that is written in WebAssembly. And I'll just show you an example of how this is. So as you can see that although like you don't really have to understand the entire code, but just the HTML exclamation mark. So in Rust, when you have an exclamation mark, it means it's a macro. So you can write HTML over here, and then these are basically used for your state and other functions. So if you're someone who's come from join the stream from a JavaScript point of JavaScript developer, and you've constantly developed in React, then I think if you're interested in creating something in WebAssembly, then you should definitely look at this framework, because this is super easy to create websites using WebAssembly. And WebAssembly are generally very have a great performance as compared to traditional. And it's not even a slight improvement in performance, it's a great amount of performance. So yeah, so that's basically how Rust and WebAssembly work together. So yeah, I think uh, yeah, so I think with this, I've come to the end of this session. So if there are any questions, then I think you can shoot it up in the comment section, and I'd be more than happy to answer them. Uh,
So I think there are no any questions, but your fan base is all there in the comment section.
oh, okay. Yeah, that's Abir and Karuna. Cool. Yeah, I think yeah, I had originally planned to have a hands-on session, but unfortunately, I got caught up in a lot of work, so that's why
Yeah.
I didn't really plan a hands-on session. But yeah, those who are watching the stream, if you would like to know more about Rust, you can go to these websites. That is thisweekinrust.org. This Week in Rust has, I think, it has articles basically which are related to Rust and I think. Oh yeah, I think Shubham. Yep. So resources to get started with Rust, like I'm mentioning over here. So there. Uh, wait. Mrunak, I think your audio is a bit. Uh, Yep, yep. Cool, cool. Yeah, so resources to get started with us. So, like, the first thing is this week in rust.org. So, this is basically a weekly newsletter. So, there are articles that are focused on Rust, like a few things that is DSA. Like, I think I mentioned earlier that writing a linked list in Rust is probably the hardest program you can find. And there are various such things that you can find in this. So, articles are really great, and you should sign up to that. And then there's the official Rust Discord server. I think the community behind Rust is why Rust has basically improved so much, is because if you think about C or C++, the community behind it is generally uh, not so welcoming. So Rust is probably the only systems programming community that is very welcoming. So I think if you join the Discord server, I'm in the Discord server. So like you can see that every 5 minutes there is a query, and the query is solved immediately in the next 5 minutes. So yeah, I think you can go over there, and there's also a Git book for Rust. That is the Rust Lang book, I guess. So that book covers literally almost everything, and you can have a look at that too. So yep, I hope I've answered your question. And yep, mscripton is basically used to compile, I guess. Uh, I'm actually not of. I think one of the things is that WebAssembly. It's been a long time since I've really coded anything in WebAssembly. I think mscripton is used to convert it's a JavaScript code to WebAssembly or C or C++ code into uh, WebAssembly, I guess. So yeah, mscripton is great because it's doing what I just mentioned. And one of the things about WebAssembly is that WebAssembly has the potential to probably replace Docker in the future. I think this is not coming from me, but coming from the creator of Docker itself. So that's pretty huge. So yeah, one of the things is that he clearly mentioned that if something like Wasm existed in 2008 or 2009, then they would never ever create Docker. So the thing is that in the future, there is a potential way in which if this Wasm gets more mature, I think Rust right now is very mature, but Wasm still needs a bit more maturity because I think it's not supported in all the browsers. It's supported in Firefox, Google Chrome, and Safari. So if you're someone who's using Opera Mini, then you can't really. There's no use of WebAssembly for you. So yeah, that's basically my thoughts on mscripton. So yeah, it does the job what it's for. And yeah, I hope I've answered all the questions. So yeah, I think uh, at the end of this, so if you're someone who wants to talk more about Rust and has any query, so you can find me in these communities. I'm an active member. I try to solve queries wherever I see that I can solve. So you can join EdiHub or Equicode or DACBITD. So yeah, or you can hit me up on Twitter or on my GitHub. So I'm usually I try my best in. So you can find in these communities, if you raise a query related to web development or something about microservices architecture or something like that, I am usually there and trying to solve these queries. So you can come there, because as of now nobody has really raised a query about Rust. I'd be really happy if someone would raise a query related to Rust and I can help them. So you can find me here. Yeah, I think this is all what I had planned for this session. So I think thank you, Runak, for hosting this session, and Karuna.
Yeah, thank you, Faisal, for this amazing session. It was great to learn about Rust, as I'm a beginner. and I didn't earlier know about Rust, and it was a great informative session to start with Rust. So yeah, thanks for it.
Awesome. I hope people watching this are inspired to take up Rust, because if companies with 10 million lines of code can take up Rust, then I think as an individual, even you can take up Rust to write, code which doesn't have bugs. So yeah. Yep. So I think I
Yeah,
like to
sure.
thank the yep. So I like to thank the Hack the Mountains community. That is the team for this session and allowing me to speak here. So thanks everyone for joining.